Hi, so I'm going to go over the last lab for remote students today. Um, First, I want to go over some administrative things. This will be the last lab for remote students. There will only be 9. Initially the syllabus said 12 labs. That was reduced by 1 for everyone, including the in-person and remote students, because I decided to have a week off for like kind of a fall break type thing. And then in-person classes were canceled due to Veterans Day because I didn't want to get the sections out of sync, and I was going to try to catch up on the remote labs during that time. But I also needed to get some grading done and some other things. So this will be the last lab. There will be 9 labs for the remote course. And I apologize, well, I'm sure some of you are happy about there being less labs, but I apologize that things haven't gone exactly as planned for the remote class, and that it's taken me so long to evaluate things. But I guess I'll start going over. Oh, also, as far as a final, there will not be a final. If you absolutely want some kind of final project as extra credit or something, you can talk to me. I know it's hard to tell, you're standing in the class right now because of how far behind I am on evaluating work. But, unless someone does extremely poorly or, is missing a huge amount of work, and if you are missing a huge amount of work and plan on trying to complete the class, then just let me know. But otherwise, the worst I will do is give you an incomplete, especially, because I have been so far behind on evaluating work, and this semester has been very difficult for a lot of people. So, don't panic about that. Just get the work in. Talk to me if you're far behind. And if you've done all the work and it's reasonable, then you don't even need to worry about that. But anyway, so if you have any questions about that, just email me. But for this week's lab, we're going to be looking at harmonic motion and springs. So we will be using, I sent you, a couple springs like this. You will also be using the Altoid scan that I sent to you. And the idea with this is you will also need to get some change. So I have mostly nickels here. Nickels are nice because they're not as exact as masses, like a mass that you would have for the in-person lab. But nickels are approximately 5 grams, and they're pretty close. And I also have some pennies, which pennies are 2.5 grams. And it's like any nickel or penny past the early 80s, which is almost all of them that are still in circulation, are 5 grams for nickels and 2.5 grams for pennies. So those work nicely for masses for this. You can use other change if you don't have enough nickels and or pennies around. But the idea was, so I gave you a mass of, the Altoids can with the clip glued to it. And so what we're going to do is just hook this spring onto the clip here. And then you're going to have to find, you can either tape the other end to something or find something to go through that and hang it from that. But you'll just need to find some way. You could even, use a string and tie the string to something. But you just need to find a way to hang this so that you can measure the distance. And so we're going to be determining the spring constant in 2 different ways. One is to just let it hang in equilibrium, so we don't want it oscillating, and measure the distance at different masses. And we can determine this spring constant based on how much it stretches for the amount of mass that we add. The other thing we're going to be doing is allowing it to oscillate and measuring the frequency of oscillation, and we'll use that to determine the spring constant as well. And we will be using the motion sensor again, so you just set that up as you did in the other experiment where we use this. And so hopefully, you can go back and look at the video on how to do that if you do not remember. And so, yeah, basically you just need to find somewhere to hang this, and then you will set this up below it, pointing directly up at it, and we'll use that to take the data. So this is my setup for the experiment. Obviously, I don't have my computer hooked up to the Arduino right now because I need it to record. But I have, hopefully you can see, the sensor is next to this tape dispenser. I'm just using that to hold the wires down so that the motion sensor or distance sensor can be pointed straight up, and I don't have to mess with it. So I've got that sitting there, and I've got the Arduino hooked up, and then I just put a piece of tape on a string over the table, and then tied the spring to it because it was kind of hard to get the tape to stick to the spring itself. So you can just set something up like this, and then so we're going to be determining the spring constant in 2 ways, like I said before. The first way is just by adding mass and measuring the displacement. So our first point, we would record data with the ultrasonic sensor and get the distance when it's just sitting here. And that would be for the mass of what this was labeled as. Hopefully you save that and know what the mass of the box with the clip on the top is. It's probably close to 35 or 36 grams if you have forgotten. So, and then I'm just gonna add, I'm gonna add 10 grams at a time. So I'll add 2 nickels to it, close it up, and then you want it to be as still as possible, but obviously it's going to move a bit for quite a while. So you can just record and take the average. So if you record for a couple seconds and then copy all of the data into Excel, I'll show this in a minute, but if you record for a couple seconds, put all the data into Excel, and then average it, you can use that as the value for the position. Then I'm just gonna add 2 more nickels and do the same thing. 2 more nickels, do the same thing, and it's just going to slowly stretch down. Also, you may need to adjust the position of the ultrasonic sensor down here some if it's not lined up perfectly. But that is all you need to do for the first part. For the second part, you are going to be allowing it to oscillate and recording that. So you're just going to want to stretch it and then have it oscillate and start recording. And I'll show you what to do with the data from this in a moment. But yeah, so you'll just record for a while it's oscillating like this. And you need to record the mass as well. And I will show you what to do with that data.